Hi, this is Lior Cohen from Radware. Welcome to our hybrid cloud application delivery demo. In this demo, we're going to be showing Radware's Alteon VA enabling a hybrid cloud application deployment that can be used for disaster recovery. Throughout the demo, we're going to be using a reference application deployment design in which we have two data centers in which the application is running, one primary as situated in Munich with physical ADCs front-ending the applications and the physical servers, and the other sitting in the IBM SmartCloud enterprise using a virtual instance of Alteon VA. Between the sites, the distributed site session protocol will be running, such that traffic only hits the designated site. At this point, we can see that all traffic is hitting the European site only, and the other site is disabled. The site selection thresholds are configurable. Let's take the example of a 10-user session deployment in which we have 10 users that are actively accessing the application, and look at how this traffic is distributed and handled on the top-hand side of the session table in the Munich data center. So all new sessions are being counted and accumulated in the Munich data center and distributed quite evenly between servers 1 and 2. Let's look at this from a DNS perspective. If we were to try to resolve the DNS name of the application servers, in this case sce.radware.de, we can see that we get two IP addresses, one actually for the SmartCloud enterprise deployment and the other for the Munich data center. Opening a website to browse through to our application, we can see that every session really results in a different application server responding to that HTTP request, effectively kicking in the local server load balancing within the primary site in Munich. If we kill one of the servers, we'll see that now we get the right alert through the console of that ADC, and in addition, we can see that the traffic now is only being directed to the active server and not to the server that's went down. Effectively, the number of sessions is only being added up to web 2 and not to the first server, because the first server is down as indicated by the red status light. When the other server goes down, the console gives us a different message that indicates that the entire VIP or server group is going down and is affected. In turn, through the distributed session protocol, the other site will effectively kick in and take over the sessions. As we see, we're refreshing on the primary Munich site, the entire site is down. And as soon as both servers are down, effectively this indicates that the entire site is down. And on the other site, the IBM SmartCloud Enterprise, we see that the other site is down. The distributed site session protocol kicks in and takes over the advertisement of the DNS entry for that site. We see at this point no more that the IP address of the Munich site is being published. And now, refreshing the web page, we're seeing suddenly that server number 3 is the active server for this deployment. So effectively, we've failed over to the cloud deployment of our application using global server load balancing and running across the Alteon virtual appliance in the cloud and the purpose-built virtualized ADC in the data center facility. As soon as the servers come back up, what we can see here is that global server load balancing kicks in accordingly, and traffic again is being distributed across both sites. And effectively, DNS entries will reflect that the primary site in Munich is back up. That's pretty much it for today. Thank you for being with us. Hope to see you in some of our additional demos that are yet to come.